Hi students, today we are going to discuss some more problems from kinematics. As we have discussed in earlier class, we are presently trying to do some questions based on different ways by which we solve problems of kinematics. In kinematics, as you have seen that in case of some problems, if acceleration is constant, then it is better to go to solve the problem via graphical method, because graphical method, it gives a clear cut idea of whole the event which is going on, and obviously by using these methods we can achieve very good marks with proper time accuracy as far as competitions are concerned. In boards also, if we solve problems using graphical analysis, then we get more advantage in explanation of the said question and the said event, and by doing so, obviously we also get good marks in our board exams or school exams as well. Here you will see that the problems which I am going to discuss today, I will solve these problems using simultaneously by two methods. By numerical aptitude, my means by saying this is that we will also achieve the results using kinematic equations and also follow the corresponding graphical analysis method, so that we can analyze that which method is good for us. See, first of all, I am going to draw the situation which we will discuss. First of all, I am going to explain this question. Say this is question number 1. Problem is very simple. It is from a very famous book to which all of the class 11th and 12th students studying across the India refer. Yes, see, a very similar problem which has been asked in many of our books is a particle has constant acceleration. Acceleration is not given to us. Just in language, it is told that particle has constant acceleration. It travels 200 centimeter in first 2 seconds of its motion and 220 centimeter in next 4 seconds. Find its velocity at t equal to 7 seconds. If we see in the given situation, we have been provided displacement of the particle for two different time intervals. First information has been given about the first 2 seconds of its motion, and then about the next 4 seconds another displacement is given, which is 220 centimeter. We have to find its velocity at t equal to 7 seconds, but as we know, there is no idea given about the initial velocity and obviously of the acceleration under which this particle is going. Now, as we have these two unknowns which basically required while solving the kinematic problems, so first of all, if we proceed with the calculation based procedure, means using equations of kinematics, then what we first have to do, remember I am doing this problem first with the method number 1. In this method number 1, I will use certain equations of kinematics. The first equation obviously will be V equal to U plus AT, where V, U, A and T have their usual meanings. And the second equation which I will use here will be the S equal to ut plus half at square, because these two equations include every element of the motion of the particle. Maybe it is final velocity, initial velocity, acceleration, time taken or displacement. So my main motto now is to use these equations with the proper values which has been given to us in the question. Here you can see, because we have been given certain informations like displacement for two different time intervals has been given to us. First time interval, it is say t1, and other time interval which is say t2. You can see here that first time interval t1 of 2 seconds, we have been given a displacement of 200 centimeter, and for the next time interval t2, which starts from t equal to 2 second to t equal to 6 second, for the period of 4 seconds, we have been given displacement of 220 centimeter. There is no idea given in this question about u, not given, and obviously v, not given. Neither acceleration a is given. Just it is told that this is constant in magnitude. Nothing is said about that this acceleration is positive or negative or of what value. Just particle have some acceleration which do not changes with time. Only this information has been given. So now how to solve this question using these equations? So for these equations, as we have two unknowns as a and u, which are very much required, and also we have another unknown which is the final velocity or velocity at any time t. So using two equations we cannot get three values. So here we will first assume these initial velocity and acceleration to be say v0 and a0 respectively. Just see, say u is equal to v0 and acceleration a is equal to a0. Now if we use these two values which we have used here, assumed here, then by using this equations in these two informations which are given to us for first 2 seconds and next 4 seconds. So if I want to calculate or use the equation number 2 to find some unknowns, then for t equal to 0 to 2 seconds, I can use the information given about the displacement is 200 centimeter. I can write equation number 2 which is given here. Using these values I can write here 200, which is the s displacement, equal to u initial velocity which we have assumed to be v0 into time interval which is from 0 to 2 seconds, means total interval is of 2 seconds. I have written value of time here as 2 plus half. We don't know a, we have assumed it to be a0, so a0 into time interval 2 seconds square. So the second equation is equal to ut plus half at square now converts to 200 equal to twice v0 plus twice a0, which yields to the final equation v0 plus a0 is equal to 100. Here this is our equation which we have got using equation of kinematic number 2 for the given set of values. Now if we proceed to the next step using the information given from t equal to 2 to t equal to 6 seconds, what I have to do, just I am using the time interval now is t equal to 2 to 6 seconds. So total t here becomes of 4 seconds. You can say time taken is 4 seconds. Here s is given to us to be 220 centimeter, time 4 seconds. So using second equation for kinematics, S equal to ut plus half at square, we can write 220 equal to 4 times u, because time taken by the particle to travel this distance is 4 seconds, so ut becomes 4u plus half into acceleration is a naught. Remember, it becomes 220 equal to twice, cut it, sorry, it is equal to 220 equal to 4 times v naught plus half into a naught into square of time interval 4 square. Now this equation finally converts to v naught plus twice a naught to be equal to 55. Now this equation at this stage of time we achieved, and by solving these two equations, one value was the previous one, for which I wrote here time to be, sorry, equation number 1, and for the second case equation number 2. So by solving these two equations together, by solving equation number 1 and equation number 2, we get v naught equal to 115 centimeter per second and acceleration a naught to be minus 15 centimeter per second square. Here minus sign indicates retarding nature of the acceleration. Retarding nature of the acceleration. Now, if we use another equation, remember here initial velocity u is basically velocity at time t equal to 2 seconds, because t equal to 2 seconds is our starting time for this second event. So we will use this u here to be v naught plus twice a naught. Remember, v naught is the velocity at t equal to 0, a naught is the acceleration which is constant. So at any time velocity of the particle, say v2, we will find using this equation. Now we have to use this velocity to be u in this equation. If we use all these terms, then this equation gives us 220 equal to v naught plus twice a naught times the time taken, which is 4 seconds, plus half into a naught into 4 seconds square. So it now becomes 4v naught plus 16 a naught equal to 220, or finally we can write this equation to be v naught plus 4 times a naught equal to 55. Now using this equation, I am stating it here to be the second equation for this particular question. Using equation 1 and 2, we get v naught equal to 115 centimeter per second and acceleration a naught to be minus 15 centimeter per second square. If we use these two values and put the values in the equation number 1, which is v equal to u plus at, if we use corresponding values, initial velocity to be u and acceleration to be a, then velocity at t equal to 7 seconds, v7 will be 115 minus 15 into 7, or equal to 10 centimeter per second. which is our final answer in this case. Are you getting my point? While solving this problem using these equations, we have to do a lot of calculations, a lot of thinking at special places. Without that, it would not be possible to solve such problems using equation of kinematics. Now, what will I do? I will suggest you a very short but very conceptual graphical analysis method to solve this problem. In that method, I will just write a single step and we got the answer directly in more clear and crystal clear vision. See, I am following the method number. In this method number 2, I am using the simple knowledge of graphs. See, in this situation, we had been provided some informations which I am going to discuss with you. I am taking here time, and here on this axis I am taking velocity. As you know, in case of constant acceleration, velocity time graph is a straight line. If we see the second sentence of the question, in which we have been given some displacements traveled in first 2 seconds and then next 4 seconds of its motion. If we talk about the interval of first 2 seconds, then you will observe that in the first 2 seconds its mean speed or mean velocity is nearly 100 centimeter per second, because it travels 200 centimeters in first 2 seconds. Obviously we can easily say that particles average velocity between 0 to 2 seconds is nothing other than 100 centimeter per second. If we talk about the next 4 seconds, then particle travels just 220 centimeters, which gives us average velocity of around 220 divided by 4 means 55 centimeter per second. Now just see, during first 2 seconds average velocity is 100 centimeter per second, but for the next 4 seconds it becomes just 55 centimeter per second. It gives us the idea to think about the acceleration. As you know, if acceleration is negative, then velocity of the particle decreases. Here, this is the main key point which we are going to use to draw this graph, because we know that for constant acceleration velocity time graph is a straight line, and from this information which we have analyzed about the displacement travel during first 2 seconds and next 4 seconds, that acceleration of the particle is negative. So in case of negative acceleration, velocity time graph will be a straight line with negative slope. If you see, just draw some curves here. So this is 2, this is 3, 4, 5, 6, and this is 7. Just draw these lines so that proper markings can be analyzed by us as per the requirements. I am drawing these lines just roughly to just visualize the situation in terms of its decreasing velocity. Just see, between t equal to 0 to 2 seconds and 2 to 6 seconds, average velocity between 0 to 2 seconds is 100 centimeter per second. So I have written particles velocity between 0 to 2 seconds at the mid time t equal to 1. I have written this velocity to be 100 centimeter per second, because if a particle moves with constant acceleration, then at the middle time its velocity is its average velocity during its complete motion. So for this interval, average velocity is corresponding to time t equal to 1 second, and for the next 4 seconds 2 to 6 seconds average velocity comes to be 55 centimeter per second. And obviously for this interval 2 to 6 seconds I have written this average velocity corresponding to the middle time, which is t equal to 4. As we know, in case of t equal to 7 seconds, I have to find particle's velocity. Say this velocity is v. Just assume it and just see this velocity time curve. This is the perfect curve for the particle for which we are doing this analysis. Just take this triangle and one more triangle, which is this triangle. If we analyze these two triangles here, one is this triangle and other is this one. As you can see, this side is common for these two triangles. So this side will have similar slope in both the triangles. And if we just use the simple trigonometry, just perpendicular upon base equal to tan theta, then for these two triangles we can apply similar triangles property. Just 100 minus 55, it is the length of this side, divided by 1 to 4, this is equal to 3 seconds, which is this side of the triangle. So perpendicular upon base, if we are talking about this angle, say this is theta, then for the second triangle it comes out to be 55 minus v divided by 3. 55 minus v is this side, and 4 to 7, this side is 3. So by equalizing these two triangles, the property of similar triangles, we can easily get 3 cuts with this 3, and finally we find v to be 10 centimeter per second. You can see here how magically and correctly and accurately we have achieved this result. Can you imagine, by seeing its last method, that this problem is of a objective type question paper? No. By seeing that this problem appears to be a lengthy subjective question which requires a lot of attention and lot of work while doing calculations. But on other hand, if we use graphical analysis method for the same problem, then it just becomes matter of seconds only. You just have to draw the graph, just have to study the similar triangles, write just one equation, and we got answer. As I told you earlier, that we will solve using graphical method for this question within. So the answer is 10 centimeter per second. Keep watching, keep listening. Today I am signing off, but remember, we will be back with new lectures soon, because something different creates a big difference. So goodbye, Shabak hai.